And welcome everybody. Here's our video about the magnetic environment around the sun and so on, the plasma sheet, and all that sort of related information from the Smash News Network least busted name in news. Let's do it. First, the heliospheric current sheet here. Earth is in a North Pole-oriented one, and we can expect to remain there for the foreseeable future. It's shown in green, that green area, that's the North Pole current sheet. South Pole here shown in red. As cycle 25 is still kind of taking its time to progress here. So let's take a look at the magnetometer data. There's the GOES 16 and GOES 17 readings. They're in a tight range here over the past 24 hours. Pretty low highs and high lows on those measurements. Here's the line of sight view showing the solar magnetogram as well. Great line of sight field plot there of the heliospheric current sheet. And next the coronal hole plot. You can see one thing I'd like to make a note of here. The North Pole and South Pole coronal holes are largely still concentrated at the solar polar regions. They're barely making their migration here, and while we do see this North Pole-oriented transequatorial coronal hole, meaning it stretches beyond the solar equator, basically it's a slow progression of the solar polar field reversal going on here during solar cycle 25. So here's a visualization of it, and that large Earth-facing coronal hole there is the North Pole-oriented one. 193 angstroms is a great wavelength to show it from the SDO. That's ionized iron, one of the many wavelengths shown. And next, let's move to sunspots. So we've got a new sunspot having formed right here. It is a beta-class sunspot. It's slightly to the north and east of sunspot 2933. That's this large one. And we're seeing a reduction here in sunspots as these two major groups have set. They are still producing some flares. 2929 has produced some C-class intensifications. And let's take a look at a close-up here. There's 2933, and you'll see the formation of 2934 right here behind it. You can see 2933 is larger than the Earth itself, but it is only alpha class, which means the likelihood of major solar flares is just not there. It doesn't have sufficient magnetic complexity to likely produce large flares. So again, flare probability has dropped. The probability monitor agrees with me. You're going to see this one known as, oh, that one's 2934, so this one's going to be 2935. The new sunspot 2935, this Earth-size sunspot 2934. And here's the flaring over the past 3 days, and you can see that large M-class flare. By the way, the proton event is now subsiding, and there's the proton flux. Those relativistic particles only took about 40 minutes to travel to Earth after that flare. They were traveling about 20% of light speed. And here is the deabsorption region readout. And you can see the proton event here subsiding, and finally a reduction in the radial blackouts associated in the polar regions. So that should continue to drop throughout the day today. Antarctican high-frequency radios should be working a little better by the time you see this video. Next, we'll look at the real-time solar wind. And we've seen a subsiding here of the solar wind speed and indeed density. Solar wind density very low here. Only about 2 protons per cubic centimeter. Solar wind speed 414 kilometers per second. The previous coronal hole wind stream has subsided. Watch our previous video for forecasts about geomagnetic conditions. We are expecting a brief period of geomagnetic unrest. We've been producing 3 space weather videos per day for the past week or so. It's a tweak to our format. Next, looking at the geomagnetic moment, Earth's geomagnetic moment, that is, from space. It's 4 hours of the geospace, and magnetohydrodynamic pressure here dropping off along with the solar wind speed and density. No real surprises there to our regular viewers. We show it daily for the past 4 years. We'll also show Earth's magnetic moment from the ground. Here's 4 hours of data on that. This is a model based on the space weather modeling framework. It uses all kinds of different features of the solar wind, the electron flux, ground-based magnetometers, space-based magnetometers, and more to get this data. Again, it's 4 hours, and we don't see any major perturbations, changes to Earth's B field at the moment. Next, a star chart. First, a solar system diagram. We'll show you the 1-week forecast as Mercury's coming past. There's where things will be in a week. We'll have a crescent waning moon by then. And here's our star chart. If you're up before dawn, you may see Mars and Venus rising ahead of the Sun. Venus, my favorite planet, the third brightest object in the sky. Leave us a comment if you know the first two. So we do see a major prominence here happening. You can see a filamentary release and collapse there in the southern hemisphere, and an even more major one in the north. So this is nearly real-time data here from the GOES 16 SUVI. This is just happening. So we'll zoom out so you can see that entire field of view. Great field of view there on the NASA GOES 16 SUVI imagery. Little crown prominence down here as well, which is a feature we typically see more at times of solar maximum. Leave us a comment. What do you think? Do you think we're going to be seeing an early solar maximum? Or are we going to see some kind of a crazy double peak? Or are we going to see a very high solar maximum? Let us know in the comments what you think is going on with the early onset of major solar activity. Next, we'll show you our coronal mass ejection monitor. We don't see any Earth-directed coronal mass ejections. What you're looking at here is the view from Stereo A's coronagraph on the left and the LASCO C3 on the right. LASCO C3 is located here at Lagrange point 1 between Earth and Sun. Stereo A is located at Lagrange 5, trailing the Earth orbitally speaking. As the Earth orbits this way, Stereo A follows at its gravitational equilibrium point known as Lagrangian point 5. So no Earth-directed coronal mass ejections in the offing today. If you haven't checked out our most recent cosmology segment, make sure you check that out. It features close-ups of the supermassive radio source at the core of the Andromeda Galaxy, known as M31 Messier Catalog number 31, and some information about a gamma-ray source within the Milky Way galaxy. In any case, thanks for tuning in to our daily space weather video segment on sunspots and coronal holes and so forth, the magnetic environment. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted, name it news.